Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about parallelogram law special cases and also we are going to study about subtraction of vectors. In the previous class we derived an expression for magnitude and direction of two vectors which are concurrent coplanar vectors. Yes, what is the expression for magnitude of resultant vector? That is r equal to square root of p square plus q square plus 2pq cos theta. So this is an expression for magnitude of resultant vector. Similarly, we derived an expression for direction of the resultant vector and it is given by the expression alpha equal to tan inverse of q sin theta divided by p plus q cos theta. So these equations we derived in the previous class and also we studied addition of two vectors. But today we are going to study some special cases related to an expression for magnitude and direction of two concurrent coplanar vectors. And also we can study about subtraction of vectors. Let us start the class. In the previous class we derived parallelogram law of vector addition. You can observe these two equations. Once again we can revise what we have studied in the previous class because whatever the special cases we are going to study in today's session, these cases are related to the equations r and alpha. When two vectors p and q are added, the resultant vector will have a magnitude r equal to square root of p square plus q square plus 2pq cos theta. So this expression we already studied. Using this equation, we are going to study some special cases. Similarly, the resultant vector that makes an angle with respect to the side AB, that is alpha, which gives direction. The direction of the resultant vector is given by the expression alpha equal to tan inverse of q sin theta divided by p plus q cos theta. These two equations are very important. This derivation carries 5 marks and using these two equations now we can study some special cases. Yes, special cases for parallelogram law. The first case, when theta equal to 0 degree. When theta equal to 0 degree, that means the vector p and the vector q both are parallel to each other. We already studied types of vectors. So types of vectors, there we have studied about parallel vectors. When two vectors are parallel to each other, the angle between two parallel vector is always equal to 0. So when theta equal to 0 degree, that indicates the two vectors are parallel to each other. These are parallel vectors. We know this expression p square plus q square plus 2pq cos theta. We already derived in the last class, you can remember. So in that equation, I am going to substitute the value of theta. Theta equal to 0 degree, substitute in the given equation r equal to square root of p square plus q square plus 2pq cos theta. Theta is how much? 0 degree. Now, what is the value of cos 0? Cos 0 is equal to 1. Therefore, we will get the final equation r equal to square root of p square plus 2pq into cos 0 is 1. 2pq into 1 will be 2pq plus q square. So what is the expression here? R equal to square root of p square plus 2pq plus q square. This is of the form a plus b whole square. Right? A square plus 2ab plus b square. Likewise, here we got p square plus 2pq plus q square. This is of the form a plus b whole square. So we can write r equal to square root of p plus q whole square. So we will get the final equation. Here p plus q whole square, it is under square root, it will get cancelled. We will get the final equation r equal to p plus q. What is the final expression? Resultant vector R is equal to algebraic sum of two vectors P and Q only when theta equal to 0 degree. Theta equal to 0 degree means these two vectors are parallel vectors. Similarly, we can write the direction expression. We know the expression tan alpha is equal to Q sin theta divided by P plus Q cos theta. Here theta equal to 0 degree. Substitute the value in this expression. We will get tan alpha equal to Q sin 0 divided by P plus Q cos 0. We know that sin 0 is 0, cos 0 is 1. We will get the final expression. When we are going to take tan on RHS side, it becomes tan inverse. So alpha equal to tan inverse of Q into 0 will be 0. 0 divided by anything will be 0. So alpha equal to 0 degree. Is it clear? Now you can observe. When two vectors are parallel to each other, angle between them is 0 degree. When angle is 0 degree, then we will get the magnitude algebraic sum of two vectors, that is R equal to P plus Q. So we got the direction, that is alpha equal to 0 degree. Is it clear? So this is the first case. Now we can study about the second case. Here I am going to consider theta equal to 180 degree. We considered parallel vectors in the first case, so theta equal to 0 degree. Now we are going to consider anti-parallel vectors, negative vectors or opposite vectors. That's why angle between two vectors is equal to 180 degree. When theta equal to 180 degree, again substitute the values. R equal to, we know the expression, square root of P square plus Q square plus 2PQ cos theta. Theta is 180 degree. We know that cos 180 is equal to minus 1. Substitute in the above equation. We will get R equal to square root of P square plus Q square. 2PQ into minus 1 will be minus 2PQ. So what is the equation? Square root of P square plus Q square minus 2PQ. Now tell me, it is of which form? It is of the form A minus B whole square. Now I am going to write R equal to square root of P minus Q whole square. It is of the form A minus B whole square. So we can write P minus Q whole square. So this is P minus Q whole square. It is under square root. It will get cancelled. We will get the equation R equal to P minus Q. This is magnitude. Is it clear? Now we can write the direction. We know the equation tan alpha equal to Q sin theta divided by P plus Q cos theta. Theta is 180 degree. Substitute the values. Q sin of 180 degree divided by P plus Q cos of 180 degree. Sin 180 is 0. Right? Substitute here. Q into 0 will be 0. 0 divided by anything is 0. So tan alpha equal to 0 or alpha equal to 0 degree. So we got magnitude and direction values. Magnitude is R equal to P minus Q. And direction we got alpha equal to 0 degree. Here you can observe when alpha equal to 0 degree, that means it is possible only when P is greater than Q. Suppose if P is less than Q, then we have to consider alpha equal to 180 degree. Right? This is the second case. Now we can study about the third case. In the third case, I am going to consider theta equal to 90 degree. When angle between two vectors is 90 degree. When angle between two vectors is 90 degree, that indicates the two vectors are mutually perpendicular to each other. So we can call it as mutually perpendicular vectors. Now we can find its magnitude. We know the expression R equal to square root of P square plus Q square plus 2PQ cos theta. Theta is 90 degree. Substitute here. Cos 90 is equal to 0 degree. So 0 into 2pq is 0. So we will get r equal to square root of p square plus q square. Because cos 90 is 0. Leave it. So we got magnitude r equal to square root of p square plus q square. Now we can find the direction. Tan alpha is equal to q sin theta divided by p plus q cos theta. Theta is 90 degree. Yes, put the value of theta here. Sin 90 equal to 1. Q into 1 will be q. So we will get tan alpha equal to q divided by p. Because cos 90 is 0. Tan alpha equal to q divided by p. So this is the third case. Is it clear? In the first case, we considered theta equal to 0 degree. In the second case, theta equal to 180 degree. In the third case, we considered theta equal to 90 degree. Just you can substitute the value of theta in the magnitude and direction expressions. You will get the answer. If theta equal to 90 degree, that indicates two vectors are mutually perpendicular to each other. When theta equal to 180 degree, they are anti-parallel vectors or opposite vectors or negative vectors. When theta equal to 0 degree, then that indicates the two vectors are parallel to each other. So angle between them is 0 degree. So this is all about the special cases related to an expression, magnitude and direction for two concurrent coplanar vectors using parallelogram law of vector addition. Now we can study the next part of this chapter, and that is subtraction of vectors. Yes, we already studied about addition of vectors. In addition of two vectors, we studied triangular law, parallelogram law, as well as polygon law, and also we considered the algebraic sum of two vectors, that is addition of two vectors. Now we can study about subtraction of vectors. Yes, what is the subtraction of vectors? It is the process of subtracting one vector from another vector. Just we are going to subtract one vector from another vector, which is equivalent to adding the negative vector to the first vector. Yes, what is the subtraction of vector? The process of subtracting one vector from another, and this is equal to adding negative vector to the first vector. So you can understand this definition by observing this diagram. Here I am going to consider two vectors p and q. Observe this diagram here. Let vector p and vector q, these are the two vectors as shown in the figure. Let a vector minus q be added to vector p. We are going to add vector minus q to the vector p. Yes, it is given here according to the definition, adding negative vector to the first vector. Right? So here we considered two vectors, vector p and vector q. These two vectors are here, it is given. In that two vectors, I am going to consider minus q. This is a negative vector. This negative vector is added to the first vector p. So here we are using laws of vector addition. We already studied three laws of vector addition. Here we are going to use the laws of vector addition to find subtraction of the vector. Their resultant gives the value of vector p minus vector q. Yes, observe carefully here. We are going to subtract the two vectors. The first vector is given, and that is vector p. Here it is given vector p. The second vector is minus q. Right? I am going to subtract these two vectors. Remember, negative vector means it is always in the opposite direction to the first vector. For example, if the first vector is along the right direction, then the opposite vector or the second vector should be in the opposite direction. So we can take it as minus q. If the first vector is in the upward direction, it will be vector P. Then the negative vector should be in the downward direction, and this is minus Q. Is it clear? Those two vectors should be in the opposite direction. According to the definition, I am going to subtract vector P and vector Q. I am going to subtract these two vectors. Right? How to subtract these two vectors? The first vector is vector P plus the second vector is minus Q. This is what we can call it as subtraction of vectors, because you can observe the definition. The process of subtracting one vector from another, and this is equal to adding the negative vector to the first vector. We have to add these two vectors. So we can write vector P minus vector Q equal to vector P plus minus of vector Q. Is it clear? So observe this diagram here. The first vector I am going to consider in this direction. Let us take it as vector P. I am going to add another vector. Let us consider that vector is in this direction, that is vector Q. Vector P and vector Q, angle between these two vectors, let us take it as theta. But here this is subtraction of vectors. According to subtraction of vectors, we have to consider another vector in the opposite direction. See here, this Q is positive. Minus Q means I am going to take that vector in this direction. So this is what minus Q. Because we are going to consider the addition of first vector to the negative vector. Negative vector should be in the opposite direction. Now tell me, what is the angle between these two vectors? Vector P and minus of vector Q. What is the angle between them? We know that total angle is 180 degree. Is it clear? Total angle is how much? 180 degree. In that, angle between P and Q is given theta. Angle between P and minus Q will be how much? Total angle is 180. Half of the angle is theta. 180 minus theta is angle between vector P and minus of vector Q. Remember, in subtraction of vectors, just we have to change the direction of the vector to the negative side or to the opposite side. Then we can easily find the subtraction of vectors. Is it clear? We considered two vectors, vector P and vector Q. Angle between these two vectors is theta. But we want a negative vector. So I considered another vector minus Q, which is in the opposite direction to the positive vector Q. Then angle between positive vector and negative vector, we got 180 minus theta. Then now we can use parallelogram law of vector addition. According to parallelogram law of vector addition, always we will get the resultant vector along the diagonal of the parallelogram. So now I am going to consider here at this point we will get the resultant vector R. So resultant vector R is along the diagonal of the parallelogram. If I complete this part, we will get parallelogram here. So according to parallelogram law of vector addition, the resultant vector is along the diagonal of the parallelogram. In this way, we have to calculate subtraction of two vectors. Yes, now you can observe this picture. We considered vector P. This is along the line A. This is what? The first vector P. Then the second vector is what? Vector Q. We considered here. This is the positive vector. But we want a subtraction of vectors. We should take in the opposite direction. So now I am going to consider minus Q in the opposite direction. Angle between vector P and Q is taken as theta. So here we have to find the subtraction of vectors. So I am going to consider negative vector, that is minus Q. Total angle is 180. So half of the angle will be 180 minus theta. So this is the resultant vector. Is it clear? Resultant vector means it is subtraction of vector. So we can write, you can take the alphabet S. S equal to, how to find the resultant vector? This is subtraction of vectors. So we can consider vector P minus vector Q. How to find its value? Vector P minus vector Q. This is what? Subtraction of vector. So here we have to add negative vector to the first vector. Negative vector plus of minus q. Minus q is what? Negative vector. Is it clear? Now we can use magnitude and direction expressions that we have derived in the previous class. Yes, now I am going to use the expression for magnitude. Here the magnitude of vector p minus vector q is, this is subtraction of vector. Resultant vector is denoted by S. Mod of S gives only magnitude. Mod of S. When you are going to write mod, that gives only magnitude, no directions. So this is an expression for magnitude. So now we can find magnitude. Magnitude of two vectors. Vector P minus vector Q is equal to, we know the expression. In general, we can write R equal to square root of P square plus Q square plus 2PQ cos theta. This expression we already studied. But here we are going to subtract the vectors. How to write the expression? Observe here. R equal to square root of P square plus, in place of Q. Q is what here? Negative vector. Negative vector means, observe this diagram here. I consider this is vector P. Let us take this is vector Q. This is positive vector. I want a subtraction of vector means we should take the direction in the opposite side. This will be negative vector and this is resultant vector. Right? The angle between P and Q is theta. Angle between P and minus Q is 180 minus theta. Now here I am going to substitute their values. P square. P means what here? P is a vector, but here we want only its magnitude. How to find the magnitude? Magnitude means it is just the length of this line. For example, if I am going to take this is O to P, the length of this O to P is magnitude. That may be positive or negative, just we are going to measure the length, that gives P square. Similarly, Q square. Here, remember this is very important. In place of Q square, here this is negative vector, means this vector we have to consider. O to minus Q. This vector I am going to consider. Only this length we have to write. Don't write negative sign. So why we should not write negative sign? Negative sign indicates only direction. But now we are going to find only magnitude. So not necessary to write negative sign. Just we have to write the length from O to, we can take it as B. The length of O to B is measured. I am going to write the value here. So don't write negative sign. P square plus Q square, keep as it is, plus 2PQ cos theta. In place of theta, what we have to write? Cos, keep as it is. Theta is how much? 180 minus theta. Cos of 180 minus theta, or we can write R equal to square root of P square plus Q square, keep as it is, 2PQ cos of 180 minus theta. We know that cos of 180 minus theta equal to minus cos theta. Sin of 180 minus theta equal to plus sin theta. These points you should remember and that you have studied in mathematics. Is it clear? So cos of 180 minus theta is minus cos theta. So minus into plus will be minus 2PQ cos theta. What is the expression? R equal to square root of P square plus Q square minus 2PQ cos theta. Here, instead of the alphabet R, we can take alphabet S. So, what is the equation we got here? S equal to square root of P square plus Q square minus 2PQ cos theta. Then now we can find the direction. We know the expression tan alpha equal to q sin theta divided by p plus q cos theta. In place of theta, we can write 180 minus theta. So substitute here, we will get tan alpha equal to. So we know that sine of 180 minus theta is plus sine theta. Cos of 180 minus theta is minus cos theta. So we got tan alpha equal to q sin theta divided by p minus q cos theta. So this is all about subtraction of vectors. We got magnitude as well as direction. What is the magnitude here? R equal to, or we can take S equal to square root of p square plus q square minus 2pq cos theta. And its direction is given by tan alpha equal to q sin theta divided by p minus q cos theta. Is it clear? So remember, in subtraction of vectors, again we have to add the two vectors, but the negative vector should be in the opposite direction. That point you have to remember here. And while substituting the values in the given equation, remember we have to write only its magnitude value. Magnitude means length. The length we have to measure, so that should be positive. It should not be negative. So this is all about subtraction of vectors. Now you can observe laws of vector subtraction. The first law you can observe, the vector subtraction does not follow commutative law. This is very important. When you are going to subtract the vectors, it will not follow commutative law. Here you can observe p minus q is not equal to q minus p. You already studied about commutative law in mathematics. You can remember p minus q is not equal to q minus p. It will not follow commutative law. Both are not same here. But when you are going to consider mod of p minus q is equal to mod of q minus p, because mod that gives only magnitude. Magnitude, maybe you will get the proper answer. When you consider magnitude, we will get the same answer in both the cases. Means that will follow commutative law. When it comes to direction, it will not hold good. So the vector subtraction does not follow commutative law. Then second one, the vector subtraction does not follow associative law. It will not follow commutative law as well as associative law. Associative law means you can take a minus of b minus c is equal to a minus b of minus c. This is associative law. But here it will not follow. So vector p minus of vector q minus r is not equal to vector p minus vector q of minus of vector r. Remember 2 points. When you are going to subtract two vectors, it will not follow commutative law as well as associative law. So this is all about subtraction of vectors. Remember, till now we studied what are scalars and vectors, what are the types of vectors, how to add two vectors, how to subtract two vectors, and also we studied 3 laws in addition of two vectors, and they are triangular law, polygon law and parallelogram law. Using parallelogram law, we got an expression for magnitude and direction of two concurrent coplanar vectors. Right? So this is all about the special cases related to parallelogram law, and also we studied subtraction of vectors.